All right, one final example that I want to go over that really trips students up, generally speaking, is motion in a current. So this shows up a lot of times. Planes flying with the wind against the wind, or boats going up river, down river. So here, let's suppose we're on a river. Here, we'll draw a little boat. And a person in the boat. Great artist. Yeah? And I suppose the current is going this way. So this has an engine on it. I don't know. Sticking in the water. Okay. Anyway, so going against the current, obviously, he's going to be going slower relative to the shore than if he was going downstream with the current. So suppose we have a trip that's going to take, or that is 60 kilometers long. Okay. And going upstream, that trip takes, let's go with 5 hours. Upstream meaning against the current. Now downstream, that same trip is going to take, say, 3 hours. Downstream meaning with the current. So what we want to know is, what is the speed of the boat relative to the water? Not relative to the shore. And also, what is the speed of the current? Okay, so those are the two things we're going to be looking for. So those are the two things that we should label with variables. So we'll let x be the speed of the boat, and I think our units make sense to be in kilometers per hour. And we'll let y be the speed of the current. Again, of course, in kilometers per hour. And of course, this is just a rate times time equals distance problem. So we can organize what we want and all of our information in a nice table. Oops. Rate times time equals distance. And we really only have two different situations here. Upstream and downstream. Now we got to think about this a little bit for the rates. Upstream, well, we've got the speed of the boat going this direction, but the current is going to be moving back in the opposite direction. To the speed of the boat relative to the shore, meaning relative to the trip that he's taking, is going to be actually the difference in the two rates. So it'll be x minus y, the speed of the boat, minus the speed of the current. And that's in kilometers per hour. Going with the current, or downstream, well, he's moving back this way, so you've got the speed of the boat, but he's going to be pushed along by the speed of the current as well. So that's going to be x plus y kilometers per hour. The time at each of these different rates, well, upstream it takes 5 hours. Downstream it takes 3 hours. but rate times time equals distance. So we have x minus y in kilometers per hour times 5 hours. Units left, of course, are going to be just kilometers. The hours on bottom cancel with the hours here. Downstream, going to do something similar. X plus y is the rate now. Multiply that by 3 hours, and our units are going to be just kilometers. But now this is a great thing because we also know the distance for the trip. That's 60 kilometers. So really, these last two boxes in the table give us a system of equations because the distance has to equal 60 kilometers. So this has to equal 60 kilometers and this has to equal 60 kilometers. So our system is x minus y times 5 is equal to 60, and x plus y times 3 has to equal 60. And there's our system of equations. And again, I'll just leave that as an exercise to actually solve the system. And if you have any more questions about this, please ask the pig.